Okay, for our last topic in this lesson, we're looking at rationalizing denominators. So rationalizing denominators means you're actually taking the denominator of your fraction and you're making it so that it no longer contains any radicals. So if the denominator consists of a square root of a natural number and it's not already a perfect square, you're going to multiply the numerator and the denominator by the smallest number that would produce a perfect square in the denominator. So there's an example up here, and you're welcome to look at that. So I'm going to look at this first one here. I've got the square root of 5x over the square root of 8. Now the denominator on this one, first of all, the directions are a little different. They're telling me to rationalize the denominator rather than just simplify. So I'm not going to handle this like I did the last section there where I just turned it into one big fraction. A second clue that I wouldn't, one big radical. Second clue that I wouldn't do that is the radicands, the 5x and the 8, don't have any kind of relationship that would help me to make them prettier or easier to work with. So my focus is on making the denominator no longer have a radical. So 8 is not a perfect square. But 8 is related to a perfect square. If I were to multiply it by 2, that would make it a 16, and 16 is a perfect square. Now with a fraction, if I do something to the denominator, I have to do it to the numerator also. Now you notice I'm multiplying by the square root of 2 because it has to be inside of a radical in order to actually perform that multiplication. If it wasn't, I wouldn't be able to do the multiplying. All right, so now simplifying. On the top, I have 5x in a square root and I have a 2 in a square root, so I can put those together and multiply them. So that would be 10x. Then on the bottom, I've got an 8 inside a square root and a 2 inside a square root. So again, I can multiply those, and that would be 16. Now my job was to rationalize the denominator, which means I can't have this radical here in the denominator. Fortunately, with what I multiplied by, though, and this of course was by design, it's not really just a happy coincidence, the square root of 16 is something we could evaluate. That's just a 4. All right, now if I could reduce the fraction, I would, but I can't reduce this one because the numerator, everything in the numerator is inside of the radical, and everything in the denominator is not. So I can't reduce by just dividing by a particular number. Looking at the second example that we have here, the radical that I have in the denominator is the square root of 2. That one is not a perfect square already, so I have to figure out what I can multiply it by to make it a perfect square. And the smallest number that I could do that with would be a 2. That's 2 times 2 makes 4, and 4 is a perfect square. So again, anything I do to the bottom, I have to do to the top as well. So on the top of my fraction then, I would just have 4 square root of 2. I can't do anything to combine them because one is like a coefficient and the other one is inside a radical. On the bottom though, I've got a 3 square root 2 times square root 2. So the two things that are inside the square roots can actually be combined and multiplied together. So 2 times 2 is 4. Now remember, my job is to rationalize the denominator, so that means I can't have this radical there anymore. Fortunately, and by design, the square root of 4 is a perfect square. That's 2. See if I have a little more space there. Oh good, I do. All right, so now in the denominator, I've got 3 times 2, which of course we can multiply together. That's 6. And then finally, this time, I actually can reduce the fraction because I do have a number in the numerator that is outside of the radical and has a common factor with the number in the denominator. They're both divisible by 2. So if I divide this 4 by 2, I get 2. Now notice this does not affect the radicand at all. The radicand still stays square root of 2. But on the bottom, 6 divided by 2 would be 3. So the simplified version of this fraction, or sorry, this radical expression would be 2 root 2 over 3. All right, one more. Okay, so for this third one, they gave me a radical with a fraction inside it. So in order to see this one properly, I'm going to actually use that rule that we learned in the last video and split it up so that I've got 2 radicals, square root of the numerator over the square root of the denominator. Now I have to focus on what I would need to multiply by the denominator to make this a perfect square. And so for that one, the smallest perfect square that's related to 3 would be 9. So I would need a 3 for that one. 3 times 3 makes 9. All right, now on the top, I'm going to multiply the 2 radicals together. So 2 times 3 is 6. On the bottom, square root of 3 times square root of 3 is square root of 9. And then again, I'm not done until I deal with that radical in the denominator. So the square root of 9 is 3. And now because the numerator is inside a radical and the denominator is not, I can't simplify these numbers. I have to leave it just as it is.